Hey guys, Dan here with Hardly Brief Programming. Today we're going to be working on our quest system. We're going to be taking a look at the location objective, which is the second objective that we want to work on or build for our quest system. But first, before we do that, I'm going to do a quick review of the quest or the issue that was found in the quest class that was brought up in the comments below, so I appreciate that. And then we're going to take a look at what we did with the collection objective, and then we'll just jump right in and start doing the location objective today. So let's just go ahead and get started. And in the quest class, we left off creating this private method called isComplete, and it returns a bool. And the idea with this method was we wanted to iterate through our list of objectives, of possible objectives for this quest, and check the variable isComplete within the objective and seeing if it is set to true or false. And the idea of doing that was if they're all set to true, and they were not a bonus, then we can return true and say our quest is complete. Now the issue comes up to in the first line here of the if statement where it says objectives I is complete does not equal false. That should say equal to false, or you can actually just delete that and delete the false as well and just put a exclamation point out front, and that's going to be the same thing as equal to false. So basically now we're properly saying, hey, if isComplete is equal to false and it's not a bonus, meaning it's a required objective, then we can return false and say our quest is not complete. So thank you again for doing that. And let's check out what we did last time in the collection objective. So the first thing that we worked on in the collection objective was actually in the interface itself for the quest objective interface, and we added two more properties. We added the isComplete and isBonus property with a get. And then once we did that, I showed you guys some art, and basically I gave a roadmap of what I'd like to complete, and that was creating one quest with two objectives, one of them being a collection objective where we collect 10 pieces of meat, and the other being the location objective. And then we just started working on the collection objective. We wanted to fine-tune it and get it up and running a little bit more. And so the way we did that, we worked in the constructor here. We added some more code in that. I showed you guys how to use these triple forward slashes to add some XML tags into your project so you can describe the method more and then describe each of its parameters. And then we worked on we created an override. We overrode the toString method here, and then we looked at creating the check progress, where basically we just compare to make sure that our current amount of whatever we're collecting is greater than or equal to the total collection amount, and if so, then we finished our collection objective. And that's really what we did in the last video. So now let's go ahead and start working on the location objective. Within Unity, we're going to be adding a few bits of code today, but the first thing we're going to work on is the objective itself. So under our objective folder, we're going to click create, and we're going to create a new C# script, and I'm going to call it location objective. If you have a better name for it, and you can go ahead and change it, but we're going to stick with location objective for now. I'm going to delete mono behavior because we don't need that. I'm going to delete the void and the start and update methods. I'm going to copy the namespace quest system from one of our other scripts, paste it above just to make sure that we're keeping the same name. We're going to delete Unity Engine and Systems Collections for now because I don't need those. Here we go. All right. And now we can work on location objective. Well, since this is objective, we need to implement the iQuest objective interface, our contract saying, hey, every objective that we create needs to have these parameters and methods, right? And now the next thing that we need to do is copy in the description isBonus isComplete title variable. So I'm going to go back to collection objective and just copy and paste the private string and bools. Go back in and go up to the top and hit enter to paste them in here. And I'm just going to actually go back into collection objective and copy title, description, properties, paste those in there, delete title. Just trying to do it so I don't have to retype it. And I'm going to grab isBonus and isComplete as well. There we go. All right, now we got that done. Now we have our location objective. Obviously, it's not doing anything, but that's good because we want to talk about how this is going to work. And what I'd like to talk about are ways to a couple of the things that we're going to need to look at and address, and they're going to be kind of project specific. But the real issue here is How do we determine our player's location? And that's going to be based on your needs, right? And your needs are going to be whether or not, like if you're in a 2D project or a 3D project, do you need to know the exact world space coordinates of your player? Or do you just need to know, maybe you have a grid-based game, do you need to know the grid area, the grid number, the hexagon number, maybe just a zone, a general location of the player. You don't need the specific world coordinate data. It's really dependent on your project. So I decided that we're going to create a separate class or structure. It's going to be a class, basically a new data type called location that we can store all that information in and use that to compare where we need to, use that to figure out where we are and compare it to where we need to go, which would be our objective. So having said that, let's go back into Unity, and outside our quest folder, I'm going to create a new folder called location, and I'm going to keep this separate because maybe you already have a way of determining your player's location, and you can kind of just implement your own variation of this into your location objective for the quest system. But this is the way I'm going to handle it for now. So we're going to create a class called location. I'm going to open that up in Visual Studio. I'm going to code some of it, and as we go through it, I'll talk about why I'm doing why, and hopefully it makes more sense. So here we have our location class. I'm going to erase everything. And basically, there's going to be a few things that this class is going to have. Or one major thing, and that's going to be probably a world coordinate. And whether or not you're working in 2D space or 3D space is going to be important because it determines whether or not you need a vector 3 or vector 2. And I'm going to include all of them, or both of them, so that we can use both. So it's like a very generic answer or solution to all your guys' problems. Hopefully they'll work. But we'll call these world chords. And under here, we're going to have a private vector 3, which will be for like 3D space. So for our project that we're working on, and we're going to call it world chord 3D. And then we're going to do another one, private vector 2, which will be world chord 2D. And I'm doing that because if you're working in a 2D project, you probably don't need the extra axis, like the z-axis that's in the vector 3. The other location type that I would like to do is a zone. So maybe you have a zone-based game, or you only care which zone the player's in. And a lot of really popular like MMOs and RPGs and stuff, when you walk into an area, like the zone text comes up and says that you've just entered the dark wood or something like that. And that's a zone-based location. You might only need that. You might not need the specific world coordinate. And so I'm going to include how we can, one way to do that, one way to handle that. So we're actually going to create a public enum. And we're going to call this zone types. And here's where you list all your zones. And I'm just going to use A, B, and and C. And then we're going to do none. So none is our generic case. A and B and C are just some general zone types. If you have some zone type names you want me to use, go ahead down and leave them down in the comments below, and I'll change them. But for now, that's what I'll do. And then we're going to create a private variable of type zone types, and we're going to call it zone. We're going to create a couple properties to access them just to keep consistent with what else we're doing. Again, so we're going to have a vector 3. We're going to call this world chord 3D, and it's going to have a get, and this get is going to return our private version of the world chord 3D. I'm going to copy this and paste it twice because we need 2 other gets. Zone type being the other one. We'll do world chord 2D here. Change that to a capital W. And then lastly, zone. And we'll change that to a capital Z. Okay, so now we've created... Oh, I forgot my semicolon here. Let's go ahead and add that. Otherwise, we'll keep getting this error. There we go. So now we've created a location class. We need to set up a couple constructors. And this is so that you can actually have variations on of location objectives. So let's say one quest, you want a specific area, a very specific point in the world that you want the player to go. So then if you're using a 3D game like we are, you can say, well, I want you to go to XYZ. And once I get to there, you can compare, make sure that they're there. Or, so that's one quest. And let's say another quest, you want them just to go to the Darkwood zone from the current zone they're in. Then you could actually create another location type that just has the zone and that does not include the world chord 3D or 2D. So the way we do that is we need a couple constructors for that. So we're going to create a couple constructors, and they'll just override each other, and they're going to be called location. One of them's going to take in a vector 3 world chord 3D. Right, so this would be the position that we want them to go to. In that location, we'll say world chord. We'll do this dot world chord 3D is equal to world chord 3D. Then we'll do world chord 2D is equal to, I'm just going to say vector 2.0. Vector 2.0 will be my null case, but really like my generic case. This probably is not the best. Obviously, if you don't need vector 2D, don't even include it. Like if you don't need a 2D location in your project, don't even have that. So you don't have to have this 0 case. But then we're going to do zone types. Oh, excuse me, zone. We'll say zone is equal to zone types dot none. And then I'm going to copy this, and we're going to create 2 other constructors. So if you pass in a 2D coordinate or if you pass in a zone, we can handle that. So this other one will be a vector 2, and it'll be vector 2D or world coordinate. We'll say this dot world 2D. It takes in a world chord 2D. We no longer need that one. Again, I'm going to make the 0 case here by just saying vector 3 for the world chord 3D. We're going to say vector 3.0. And this just sets the vector to 0, 0, 0, if you didn't know that. And then zone, we'll do zone types none. And then lastly, we'll change this constructor for zones. I'm going to copy that, paste that in there, and change this dot zone. We'll change it this dot zone is equal to zone. And now we have a location. Now, if you don't get what this is doing or how we're going to use it, I'll show you. We're actually going to be creating a method called compare, and I'll write that in now. But we aren't going to implement it until probably the next video. So we're going to do a public bool compare. I think we're going to return a bool. We'll do public bool compare, and it's going to take a location. We'll call it location. And this is just going to return true for now. All right. So let's go into our location objective, and let me discuss how this is going to work. And hopefully it all comes together. It makes a bit more sense, and you don't think I'm just being crazy. So here in the location objective, we have this method called check progress, right? And check progress is going to have to look at something like your player and figure out where they are and if they're in the location that we need to be. Now we don't have any variables in here to determine the location where we need to be, so we need to create one, and that's going to be a private location type, and we're going to call this target location, right? So this could be a zone, a 2D chord, or a 3D chord. It's up to you depending on what you want, and then you can even add more to this. So if you have continents and all that stuff in your game, you can add more to the location class. Right, it just doesn't have to be those 3 things. I just define those 3. If you have others, you can add them to it, and you'll just have more types of areas you can make a target location. So our target location will be either a zone, a 2D coordinate, or a 3D coordinate, and that's what we're going to be checking in our check progress. Right, so we're going to have something like an if statement where it's going to say if, and I'm going to write this out in comment form, and then we'll actually code it. So it's going to be like if our player's location is equal to our target location, then we are complete, right? So how do we do that? Well, we don't have any player class, or in this project I don't have a player class. I don't have a way to check my player's location yet, and I'm not going to talk about how to implement that in this video like directly. There are a couple ways you can do it, and that's again dependent on your needs. If you need to update your player's location every single frame, if you need to know exactly where your player is at all times, then you'll probably have some sort of method or something that does that, or some sort of event call. You might maybe you just need to know when a player enters a specific area, a zone, like a larger area, and you might just have world colliders in your project, which send out events updating. All right, sorry about that. My phone went off. But here we go. So I was in the middle of talking about what the check progress method does for the location objective. So I started writing out, and I said, if player's location is equal to our target location, then we are complete, and we have finished the objective, right? So how do we implement that? Well, we started talking about we don't have a way to determine our player's location yet in this project. If you already have one implemented, then that's where you're going to want to output it or check it. And there's a couple ways to do it, and that's going to be really dependent on your project. You might need to know your physical player's location every few, every frame. You might only need to know it when they're in certain areas. And again, that's super dependent and specific on your project. Here, I'm going to try to make a very general way to do it. Well, I'm not going to check it. We're going to be using the location class to kind of mimic that it's working, I guess. But what we'll do is we're going to create another class called player. And this would be, you can imagine, this would be the script that's attached to the player that stores a lot of the player's information, right? It'll probably have a stat variable, like a stat object that has all of its stats. It might have an inventory object that has all of its inventory. It's going to have its quest list that stores all of its active quests, that kind of thing. So let's go into project folder, and outside the location folder, we're going to create a new one, and we're going to call it player. And I'm going to create a new C# script. I'm going to call it player. And let's open that up in the Visual Studio, and hopefully, again, when I go through this, you'll kind of understand what's going on. So I'm going to leave mono behavior attached to this. And here, I'm going to write a private static type location, and we're going to call this location, lowercase. And then we're going to create a public static version, static location, and we're going to call it, I guess we'll say get location. I don't really like that, but we'll say that for now. And we'll do, I want to do that. All right, get, and we'll say return location, right? Okay, so again, let me write some comments just so you guys know if you're coming back to this later. This class will have references to your inventory, stats, quests, other information, right? This is just all the general information your character's probably going to have on them at one time. This class will have it. It'll be a class that you can access and call on. And so I wanted to be able to say player.getLocation, right, which would return the player's active location possibly. And so in location here, or excuse me, let's go back into location objective, and now I can save that. Where am I at? So in location objective, now I can actually write this if statement. So now I'm going to say if player, which is that class we just created, get location, which will store a location variable, dot compare, which is that method that we created and we haven't done anything with yet, that's in our location class, that compare method here, right? And we can say dot compare, and then we can pass in the target location. And then if that returns true, then we can set is complete is equal to, let's get the private version, is complete is equal to true, right? Else is complete is equal to false. So in this case, we're saying, hey, our player, get their location, compare that location to our target location. If they're the same, hopefully, which we'll go look at and just do it in just a moment. If this returns true, if this compare method returns true, then our objective is complete. So hopefully you understand how that works. Let's go into the location objective, the location class, and we'll write the compare method pretty quickly, and then we'll end the video for today. So the compare method, this isn't the prettiest method, but what we're gonna do, we're gonna have a couple if statements, and we're gonna say if our world chord 3D. Again, we can fine tune this later on, but if our world chord 3D does not equal vector 3.0, which is my null case as I'm calling it, and our location dot world chord 3D. Right, so location.worldCore3D, this is the one we're passing in, is equal to our world chord 3D, which would be our player's world chord 3D. If that's equal to it, then we can go ahead and return true. Pretty simple. Okay, so now I'm going to copy that, and we're going to create an else if statement. And we're going to say else if our 2D location. So if that's not true, but our 2D location is true, then we're going to want to return true. And if you haven't guessed it, we're going to do the same thing, but we're going to do it with our zones. Right? So we're going to say zone does not equal zone types dot none. So that's our 0 case, or our null case, if you want to call it, our generic case. If it doesn't equal that, then we know it should equal something else. And that something else, it should be equal to the location we're comparing it to. So it'd be location dot zone, and then the zone that we pass it in. So it'd be zone, the private zone. So if they're equal to each other, we'll return true. Else, if all else fails, we're going to return false and say, hey, they are not equal. Right? So this is a very, very simple compare method. Not the prettiest because it's just a bunch of if statements. I'm sure we can write this a little bit better, and we can address that later on. But now we have actually implementing a compare method to check our player's location versus the target location of where we want to go. So that means in my location objective, when I create one, which we haven't created the constructor yet, we'll do that in the next video. But if I create a location and I say, hey, I want my target location to be zone B, which if our player's from zone A, which was the quest that we wanted to do, then I can say, okay, that's fine. Let's check our progress on it. However we decide to do that, and we'll check our progress based on this method here, the get location, and then, or excuse me, the compare method that we created in the location class. So hopefully that makes sense. If it doesn't, please leave your comments down, your questions in the comment section down below. Otherwise, all this will be available to download off the GitHub page, which is also in the description below. Otherwise, I'll talk to you guys next time. Have a good day.